started with this basic idea of how could we quickly and efficiently understand how much risk really is there in this public loan program. Fascinating question. We had a great team on board. We said, have at it, guys. Let's figure out what we can do.
So, hello everyone, my name is Michael. I'm founder and CEO of GraphAware, based out of the UK, with some strong partners in the US and UK. But I'll let Vince introduce himself.
Yeah, sure. Hey everybody, I'm Vince Bridgeman. I run the national security practice at Redhorse Corporation. We're an engineering services firm based here in Roslyn, Virginia. And we also have some reps from our UK subsidiary. Put your hands up, lovely people. Dan and Helen. So if you're UK based and interested in this technology, please look them up.
Cool. So our mission as a company is to help anyone find truth in data. And our thesis is that the world is more and more connected. The data that we produce are about this world, so therefore also more connected. And the tools and technologies or a lot of people use to understand data is no longer fit for purpose. So our sort of mission is to embrace connected data and basically turn what traditionally are tables and indexes and so on into a graph or a knowledge graph that gives you a lot of opportunity for different kind of analysis of the data, for looking at it differently and for actually efficiently traversing through the network, analyze who is who, what is what, how things are connected, and also being able to understand that very easily. What we have done in the last 5 years, we've built this platform that we call GraphAware Hume, and that basically is an end-to-end solution that allows organizations to bring data into one place, which we call a single view of intelligence. So there's some data engineering functionality. It then allows you to do very efficient and streamlined intelligence analysis. I'm not going to go into details. But some really interesting, fast, efficient, understandable and explainable analysis on that data. Then because the data is already represented as a network, that gives you opportunities to do more advanced kind of analysis. So not just pathfinding, not just traversing through the network, but also computing things like who's the most important person in the network, doing things like predicting missing links, that either you're missing because your data's not complete or that because we don't even know that the link could be there, and things like this. And ultimately, what this does to organizations like police forces and intelligence agencies is brings the entire organization together around data. So there's a product basically they can collaborate around and share knowledge and insights. Now, how it works is very, very simple. At the bottom, there's an engineering component, data engineering component, brings data from all kinds of different data sources into a knowledge graph. We use Neo4j as our data store for this, so that's a graph database. And then there's an application layer where the magic is the analyst can ask questions, and the graph provides the answers. So that's all good. Then what you can do is, apart from all kinds of other cool things, is do things like shortest path questions. So basically you have two people, are they connected in any way? Yes or no, boom, the system immediately gives you the answer, right? And this is one of the very powerful things about graphs, is because not only it's fast, but also you don't have to know how these things could be connected in order to find out whether they are connected. Imagine writing that in SQL and kind of enumerating all the possible combinations, right? Now, the tricky thing here is that you actually need the things to be connected for you to be able to ask these questions. So this situation is very common. You have 3 different companies here, and you have supposedly 3 different people. In reality, these are the same. This is the same person, right? Owning these 3 companies. But perhaps because this data comes from a different data source, each one of those, if they're not connected in the graph, it's pretty much useless. So that's where we started working with Senzing and kind of enhanced the architecture by a lot of boxes. But all this does basically is it captures the changes in the graph, pipes them through a queue to Senzing. We built an API, a kind of generic API on top of Senzing so that it can run as a microservice side by side with Hume. It does the resolution. We write it back to the graph in some shape or form. And this is really up to the customers to decide exactly what's written back. But one way of representing this is basically a group node of resolved entities where we preserve the original records and the original links. So that gives you the opportunity to also preserve permissions on the data if they're different from different data sources. And the analyst view could be something like this, where the entity, the same guy who owns the 3 companies, is one node. But of course, you have the option to kind of zoom into it and see the original constituting records. There's different ways of modeling this data in graphs, but that's for another presentation. The other cool thing about Senzing is the what we call the why API. We can explain to people why it made the decision it made, and so you can either expose this to the analyst or to the end user and say, here's why these 2 records are the same. Or sometimes if you want to be fancy, like our CTO Chris, you pipe this result through an LLM and actually get a human readable explanation as well. But that's for fancy demos. I'll hand over to Vince for him to share some real stories.
Awesome. Thank you, Michael. So I'd love to tell you some cool classified use cases, but this is not the right venue. So I'm going to tell everybody an interesting fraud story because I can talk about it. As Michael suggested, right, graphs and entity resolution kind of go hand in hand. And we recognized this pretty early on when we started our graph story. We had been working on some classified programs. We'd been working on a couple other programs, but we really wanted to kind of test out this thesis end to end. And sure enough, you guys remember a thing called COVID. COVID happened, and we saw this tremendous, interesting opportunity to test out some of these ideas. Started with the Paycheck Protection Program. Everybody had to stay home from work. The Congress authorized a program to hand out loans to help businesses mitigate the impacts. Everybody remembers that. A lot of loans were given out, whole lot. 11.8 million, in fact, $800 billion, almost 5,500 lenders. That's a lot of loans. And as you imagine, in the rush to get those loans out, some people took advantage of that. And when we started to see these headlines, right around the end of the program, we thought that's a fascinating problem. We should dig into that. Fortunately, we had a good relationship with the folks at Senzing, and everybody know Boris Kosovsky. Boris, if you're around, put your hand up. Boris said, well, we should dig into PPP loans, and we said, yes, we agree. Let's do that. So we did, and we started with this basic idea of how could we quickly and efficiently understand how much risk really is there in this public loan program. Fascinating question. We had a great team on board. We said, have at it, guys. Let's figure out what we can do. So that's the business problem. And our basic hypothesis was we wanted to test this idea of entity resolution, knowledge graphs, and graph analytics, as Michal talked about with the Hume platform. How could we do this as fast as possible to get to an understanding of how much fraud might there be in the loan? And then could we serve up those answers provably in a dashboard, we use Domo, and then provide prompts to investigators who might want to then pursue those for criminal investigations. It was a great exercise, a good chance to get my team really conversant in the technology, and to do it against a real data set, which was fascinating. We're going to focus our talk today on kind of that thesis of entity resolved knowledge graphs. So we're going to talk about what we built in this red box and how it worked, and we'll give you some examples. And I'll try to keep it interesting. So this is what the MVP looked like. We downloaded the public PPP loan file from SBA. We partnered with a business entity data provider, and through our relationship with Senzing, we got some Dow Jones watch list data, some data from Nomino, and then we got some address validation data from Melissa, right? Because people who are fraudulent about their businesses might lie about where their business is registered, like, I don't know, a post office box, right? We used Senzing, again, as the primary entity resolution engine, wrote that through 3 separate Senzing databases. They ended up about 1.5 terabytes, and then wrote that into Neo. And then we used Hume and some functionality within Hume that allowed us to run some compound rules against the database. And those rules, we worked with Boris and some loan fraud experts. Those rules are all expert defined. These are rules that any fraud investigator would look for. The most important part is that we were allowed to, because we're writing to a knowledge graph, and that knowledge graph had a lot of rich information present, we could write context-aware rules. So we could write rules that required a traversal of the graph to go look at other things that were related to the question in hand. In this case, was the loan fraudulent or not? So the context-aware nature was really important in our rules design. Those rules were all numerically scored based on what our fraud analysts, consultants thought meant higher or lower amounts of risk. Those scores were aggregated up so that we could have a one-to-n prioritization of the likelihood of fraud across all of those 11.5 million PPP loans. Because they're all persisted in the graph and the source data was persisted, in other words, I could go all the way down and see what the original source record said. It was explainable for anybody who wanted to dig in, and verifiable. So you can see the classes of rules. And again, these rules are not designed to say whether a loan is or isn't fraudulent. It's really designed to, one, kind of capture the aggregate risk in the program, and two, give an investigator a starting point to conduct an investigation, and then a referral to a criminal investigation. So again, multiple classes. This is about surfacing risk. So let's jump into some of these rules real quick. Here's an example of multiple loans. So this is one business. We validated that that business has been entity resolved properly, and that business had 23 different loans, all given essentially within a couple months period. When you kind of dig into the particulars, that business had 23 separate loans, but each loan only had one job covered by the loan, which is not how the loan program is supposed to work. The loans were given out from 9 different lenders, and when you look at the lenders, as I look at that closely, there may be one duplicate loan that maybe came from a duplicate in the PPP loan file, but the lenders they're pretty diverse, right? So whoever got these loans was definitely shopping around, okay? The other thing that's interesting, and this is one of the beauties of Senzing's entity resolution, is this idea of a possible match, right? You can tune the match, you can tune the intensity of when you identify a possible match, but that possible match gives you clues to other things that might be going on in the data. So if you look to the left, these possibly related links, that's how we titled it in the database, these possibly related links, those are also businesses that also got interesting loans. And the links are that they shared addresses. And this one business with the 23 loans reported different addresses on different loan applications. So there's some sort of conspiracy potentially happening here that's definitely worth digging into. That's a fun one. Watch list connections. So let's say you give a loan to a business that looks completely on the up and up, but you didn't know that that business has a tight association with somebody who's already on a financial crimes watch list. That person's name never shows up on the loan application, but you can look in the financial crimes watch list and find out that that person used to work at that business address. Now you have a question to answer. Is that person still involved with that business? And is that business potentially taking out a fraudulent loan, inflating the loan amount, misstating the number of employees? It's a great kind of investigative cue that you'd never catch unless you run those two data sets against entity resolution. All right, loans greater than $10 million. So during the first tranche of PPP, you weren't supposed to get, one business was not supposed to get more than 10 million in loans. And as you can see, we've got one business here that got about 19 million in loans across five different loans around the same time within a month. In fact, all approved the same month. They were not a combination of first and second draws. Again, we put some time bounds on this query. And the other interesting thing is, again, we've dragged along that watch list record, and we see that this business has already been flagged for regulatory issues. So again, perfect prompt for an investigator, and a good example of how you kind of quickly run through these rules and surface risk. Suspicious registration activity. This is a fun one. Imagine for a second that you had a business that closed that was unsuccessful, and then this loan program comes around a few months later. You might be tempted. We think that's what happened here, right? Business number 2 got a loan, but that loan was given before that business was formally established in the state's business registry. Business number 1, owned by the same individual, with almost the same name was closed 2 years prior. So what it looks like is that this enterprising individual may have filed for a PPP loan for a business that doesn't exist, and then set up the business to substantiate the loan. So this is, it looks like a pretty clear-cut case of that. And it might have been tempting, right? A lot of people were facing hardship, so I'm not judging the motive here, but certainly it's not legal. High salary variance, right? This is a good example of some of the rich things you can do when you have kind of a detailed knowledge graph. In this case, we were looking to see whether businesses were inflating the salaries of their employees to get bigger loans than they would have deserved. So were they misstating the salary of their employees? That was part of the loan application. And so for this rule, what we did was we actually looked, we grabbed a data set that kind of had the, at job-specific rates of compensation. So this is like a salary survey data set, all the way down to, in our case, we used, I think, congressional districts, because that's how it was reported in the PPP loan program. But, and then we said, we built a test that said, is this a significantly higher than what we think is the expected normal distribution of a salary? In this case, we found a business where the salaries were almost 1.2 times higher, so 117% higher than what would have been the normal salary for that job in that district at that time. So another pretty clear cue that we should look into this one. All right, so I'll kind of close with a fun one here. Not necessarily a hard rule, but we thought, well, let's write a query and find out how many foreign-owned, beneficially owned businesses got American subsidized taxpayer dollars in the PPP loan program. So we ran, I think we ran this query a couple different ways, but essentially a single line of cipher just saying, find me all the connections all the way back to a foreign beneficial ownership. And this is the result of one of those queries. I believe this is Chinese state-owned corporations. I wasn't able to go validate because one of my team members is out ill, but this is essentially the power of the knowledge graph. I can ask a very straightforward question and get a very rich answer. I'll close with a little philosophy because I'm big on this. How do you think about the power of this combination? It's pretty straightforward, right? So everybody's seen some version of this, right? This drawn from systems thinking, but the process of getting to where you can make a good decision, right, is the process of successively understanding things in a richer and richer way. And I like this framework because it really explains the value of entity resolution and graphs quite well. You have individual points of data that, when understood in context, constitute information. That information, understood in the context of other information, allows you to understand patterns, right? As I was showing you, there's a lot of patterns in our rule sets. Once you can understand the patterns well enough, then you can begin to distill that down to understanding principles. And a knowledge graph is essentially a knowledge graph combined with powerful tools like entity resolution is essentially a way to automate that understanding of relationships, accelerate the understanding of patterns, and that frees you up to spend more time understanding the principles and making good decisions with your data. In short, knowledge graphs accelerate decision advantage. And again, I wish we could have talked about some of the amazing other things that we've done for our clients. We're doing this for the Defense Department and the intelligence community, and we have been for several years. It's available to DoD customers via the TradeWinds marketplace. The Chief Data and AI Office of the DoD runs the TradeWinds marketplace, so this is awardable under TradeWinds, and is currently finalizing its deployment to IL5 in Cloud One for the Air Force for an Air Force project we're doing. So the rest of my team is here. If you got technical questions, guys, put your hands up over there. These are the guys who make this stuff work. So if you got tech questions, let me know. But it's been a pleasure chatting with you, and we'll open it up for questions. Yeah.
We have time.
Get a mic I can take up to,
Well,
the
there's
crowd?
there's
We use
another.
this,
1, 2, 3.
Yeah, that works.
You can
Yep.
take this one for questions.
We got a question. Just gonna stand right here in the middle.
That good, huh?
I think you nailed it.
All right. That's it. Cool. Thank you.
Well, actually, again, I have a question. Yeah, I do. Often customer-facing engagements, I work for Senzing, I run into customers who are really sophisticated users of a graph database, pick one, right, Neo4j, and they think they can do entity resolution with just the graph database. I usually win the discussion, but I want to hear how you address that.
Sure.
Okay. Hello. That's a tricky one to answer in a room full of Senzing roll-up banners. There are customers who will attempt to do entity resolution on their own, right? With other tools, by defining rules themselves and hoping it'll work. And it may. The question is, do you want to spend 2 years fine-tuning it, or maybe 15, I don't know, Jeff can tell us, 30, right? Or what is it? Or do you want something that works out of the box, right? So we don't respond to them as if Senzing was the only solution on the planet, but we give them a choice, you know. Do you actually want, it's the same like you want to buy a graph database or you want to build one. Good luck, that's another 20 years of your life. So it's possible, but it's never going to be quick time to value, and it's probably not going to work as well. I don't know if you have a view.
Yeah, absolutely. I'll tell a story. I'm not gonna name names. I got hired several years back by a federal customer to essentially build a fraud system around. Well, I can't even say what it's around. To build a fraud system, and I think that's you.
It's me.
Yeah. And we pitched them. We actually showed them some accountable stuff, and they were like, "This is awesome. We want it." And then we showed up to day one, and they said, "Yeah, but you have to use our own internal entity resolution service." And I think that project lasted about 9 months before COVID eventually killed it. But the bottom line is that their entity resolution service barely worked for 25% of the cases. So I come at this from the perspective that entity resolution is really hard. And when we first started working with Senzing, it works, it's understandable, it's explainable. There are some cases where you don't have unique identifiers and you have to have, you know, some creative ways to kind of go the last mile. And you know, Graphs is good at that, right? But it's more expensive and it's more of a trial and error thing. I always start the conversation with my customers with the question of how fast do you want to move versus are you willing to pay a little bit more for some technology? So yeah, I agree. It's a trade-off. But when we have these problems to solve, the place we start is with an understanding that Senzing solves most of them pretty quickly. So. One more?
One more question, I think.
So let's say, God forbid, there's another COVID that comes around and we need to issue a bunch of loans like this. What do you take from your learnings of this to do that the third time?
Jeez. I mean, well, that's a whole complex conversation that has little to do with technology, but I would say clearer rules and putting the risk more properly on the banks giving the loans. There are some fascinating cases where, like, if you dig into this, like down in Miami, there was a loan officer coaching applicants how to defraud the PPP loan program and taking kickbacks. And so any bank fraud department that was even halfway paying attention should have seen these things. But the overall, I think the tenor of the crisis was that we should give out the loans and then worry about the fraud later, right? So I think going into it kind of clear-eyed and having some expectations of shared risk would be a better way to approach it. By the way, we try. Well, I won't say that. Never mind. I was going to say early on we tried to bring this to people's attention, and they weren't so interested. So.
I will maybe add from the technological standpoint, the rules that Vince was showing earlier, in practice you combine them all together and you compute a risk score. And then you can, with a single click in the platform, essentially understand why the risk score is what it is, right? So if it's from 0 to 1, if something's high like 0.9, you say why, and then you immediately get, oh, it matches this pattern, that pattern, that pattern, that pattern. In most of these systems, including Hume, you can very easily set some alerts that run automatically, detect patterns, detect all these kinds of things. So technically, it's extremely easy before you approve the loan application to score it, and if it's above a certain threshold, let a human actually take a look at it, which is anyway what banks are doing when authorizing credit card transactions and all that. So I from a technical standpoint, this would be quite easy, I think, to prevent some of this fraud at least.
Agreed. I got one over here.
Thank you.
Over here.
Hello. You brought up that example of the loan officer. Can you hear me?
Yeah.
Yeah.
Okay. That kind of piqued my interest a bit. Could you see this technology being used to identify sources of bad data, not just ways of using good data to identify bad actors? Is there any way, could you somehow use that graph to trace back?
Yeah, I mean, I think I'll say this, and I think Jeff is probably the first person who made this point explicit, at least to me. You can't hear me? Yeah. So I'll say that the answer is yes. And I think Jeff made this point way before I did, which is sometimes the bad or fraudulent data is highly useful in uncovering the intent of fraud, right? And so that's where the ability to do things like entity resolution, but keep the lineage of the actual source record available to an analyst is incredibly useful. And then that opens up opportunities for additional rules or analytics or machine learning models that look for those kinds of patterns. Is that helpful?
Yeah,